Let us start. So good evening, welcome to the session. So this is our third session on simple harmonic motion or oscillations. So yesterday we have discussed some really interesting things. We have derived a few things. So let us quickly write them down, whatever we have discussed in previous session. Okay, once we do that, we do some problems and then we will move on to the next discussion. Right. So what is the idea with which we have started? In any simple harmonic motion, in oscillation, this need not happen. But in oscillation, which a special case of oscillation is simple harmonic motion. In simple harmonic motion, force should be proportional to displacement. Displacement, I have used the letter X. If you want, you can use S, or somebody uses Y. It's okay, any letter is fine. But generally, we use, in this chapter, we use X or Y. So proportionality, we can write it as equality as F equal to Kx. But we know that displacement and restoring force, this is not just force, this is restoring force. What is this restoring force trying to do? What is it trying to restore? It is trying to restore the position to equilibrium position. Equilibrium position is always a stable position. Okay, if a particle is at equilibrium position, even if you disturb it also, it will try to come to the equilibrium position. So since restoring force and displacement are opposite in direction to each other, always, because as you displace it from the equilibrium position, restoring its force is trying to pull it back. So that's why there is a negative relation. They are proportional to each other, but in direction wise, they are opposite to each other. So this is the basic with which we have started. Now, what is acceleration? Force, you can write it as ma. Then acceleration can be written as minus k by m into x. Simple relation from the first, we got the second. And if you remember, k by m, we got some interesting result about k by m. What is that? Do you remember? In yesterday's discussion, what did we get k by m as? K by m.
Omega square.
Very good. So we got this right. Omega square is k by m. We have derived that yesterday. So next time onwards, whenever you see k by m, you can replace it with omega square. K by m is omega square. What is omega? What is omega? Angular frequency, right? So we can write A equal to minus omega square into x. Okay, right. So after this, from acceleration, we have written acceleration as d square. We can also write this as, acceleration can be written as d square x by dt square. Because x is taken as displacement, we have written it as d square x by dt square. If displacement is taken the variable y, then I will write acceleration as d square y by dt square. If displacement is taken as s, like in kinematics, we can write acceleration as d square s by dt square minus omega square into x. All these came from the first equation. From this, we got this. This and this both are exactly same. This equation and these two equations are exactly same things, right? So this equation we have rearranged slightly, and we have got the relation between velocity and displacement. This is the relation between acceleration and displacement. Now from that, we got relation between velocity and displacement. What is the relation between velocity and displacement? Anyone? You can go back if you want. What is the relation between velocity and displacement? Yeah, we got it here. See here. V equal to omega into root of a square minus x square. V equal to root of k by m we got, which is omega into root of a square minus x square. So if displacement is taken as y, you can write it as a square minus y square. If displacement is taken as x, you can write it as a square minus x square. Since displacement variable we have taken it as x, I'm writing it as omega into root of a square minus x square. So we have acceleration and displacement relation, which is a simple relation which we got from basics of SHM. From that, we got velocity and displacement relation. So can we rewrite this again? Shall we rewrite this again? See, So velocity, I'm squaring on both sides. Omega square, V square is equal to omega square into a square minus x square. See? So let me rewrite it. V square is equal plus omega square into x square is equal to, I hope you're following. The second part, first part is omega square a square, second part is minus omega square x square. Minus omega square x square, I'm putting out to the other side. Then it becomes plus omega square x square. What is left on the other side? Omega square into a square. Right? So look at this equation. This also represents SHM equation. The reason is, this is the basic of SHM. From this we got this. So this is also equation of SHM because this is, with this we got it from the very basic of SHM. And from this, by a small rearrangement and then integration, we got this. So this also we can call it as, this is also representing simple harmonic motion. In a simple harmonic motion, velocity and displacement are related in this way. And a simple harmonic motion, acceleration and displacement are related in this way. Okay, right. So this equation looks a little bit familiar. So if you observe, see, you might see these equations in different forms. That's why I'm trying to write multiple times so that you get familiar with them. Have you heard of differential equations? Have you heard of differential equations? No, it is in mathematics. I don't know if you're introduced to it, but see this one, d square x by dt square. Differential equations means it's nothing but differentials. If differentials are present in some equation, we call it as differential equation. Simple as that. That is what you need to know right now. D square x by dt square plus omega square into x is equal to 0. Same thing, I'm just writing by putting minus omega square x onto the other side. So if you write it in this form, we call it as differential equation. Simple harmonic motion expressed in the form of a differential equation looks like this. Have you written anything, something completely different from what we have discussed? We have written very, very simple things by rearranging this way, that way. Okay. Because in exam, they might ask you questions like, which of the following equations might represent a simple harmonic equation, simple harmonic motion? Okay. They might give you one of these equations. These are just rearrangement of one another. Okay, fine. So look at this one. Look at this one. I'll just, on both sides, v square divided by, I'm sending this, I'm just dividing both sides with omega square a square. Okay, omega square a square. If I divide both sides with omega square a square, what happens is on the right hand side, it becomes 1. On the left hand side, it is v square by a square. I hope everybody knows what is a. What is a? What is capital A here?
Amplitude.
Very good. It is amplitude or the maximum displacement. When a particle is oscillating to and from motion from the equilibrium position, what is the maximum displacement possible? That we have named it as capital A here. Right. What is here? I'm dividing every term here with omega square a square. Okay. Why I'm dividing, you'll understand. So I'm dividing omega with omega square a square. What happens here is omega square x square divided by omega square a square. Omega square gets cancelled. What remains is a square. Does this equation look familiar? Does this equation look familiar? No? Yes? Here, x is a variable, right? V is also variable. Is it variable or not? Variable means, is it changing with position or time? Is x changing with time? X is displacement. Is displacement changing with time? Oscillations are happening. With time, the displacement is changing or not? With time, displacement is changing, right? And with time, is the velocity changing? Velocity and displacement are changing. No, they are varying, right? They are varying with time. They are varying with the displacement. So v and x, they are variables. Whatever varies, we call them as variables. So v and x are variables. Omega, is it constant or is it variable? Omega is angular frequency. Omega is angular frequency. If you don't disturb, once you create the oscillations and you just don't disturb the system, what happens is frequency or angular frequency, that depends on what mass you use and all that. But once you create the oscillations, the time taken to complete the oscillation is time period. And that time period decides the frequency or angular frequency, because f equal to 1 by t, omega equal to 2 pi by t. If time period is constant, f and omega are also constants. So here omega and a are constants. Is it not looking like something familiar? Look at this one. X square by a square plus y square by b square is equal to 1. Have you seen this equation anytime? Have you seen this equation anytime?
Ellipse.
Very good. So this is the equation of circle, and this is the equation of ellipse. Ellipse becomes circle when a and b are equal. If if you replace b with a, then we can write as x square by a square plus y square by a square equal to 1. That a square, you can send it on to the other side. It looks like this. So x is a variable here, y is a variable, a and b are constants. Now see here, x is a variable, displacement is variable, velocity is variable. Now this equation is exactly looking like this. So if you draw a graph between x and v, if you draw a graph between displacement and velocity, how is it going to look like? It is going to look like an ellipse. Let me draw x on x-axis, v on y-axis. If you draw a graph, it is going to look like this. It looks like an ellipse. Okay, fine. Is it understood till this point? I've discussed only simple stuff. There is no trickiness here. But if you want me to explain anything once again, I'll be happy to explain. Purnashri, are you following?
Yes, sir.
Very good. Venkateshwarlu?
Yes, sir.
Okay, good. Right. So till now we have discussed two things. One is acceleration. Second is velocity displacement. First is acceleration displacement. The second is velocity and displacement. Right. Next, third relation. I told you there are three variables: displacement, velocity, acceleration. These are the variables. Okay, these are dependent variables. They depend on time and other things. And t is also there. We just want a relation between all of them. Well, how many relations can you form? One relation, two relations, three relations, fourth relation, fifth relation, sixth relation. Totally 6 relations we want. Totally 6 relations. What do I mean with the 6 relations? Relation between displacement and velocity, relation between velocity and acceleration, relation between acceleration and time, relation between displacement and time, velocity and time, acceleration and time. Totally 6 relations we want. If we know those 6 relations, we know the relation between any two parameters. Correct? So we've already discussed two things. So let me write here. We want relation between xv. We want relation between xa. We want relation between va. Right? And we want relation between xt, vt, at. These are the 6 possibilities, 6 possible combinations we can think of. So if we can understand the relation between all of them, all the 6 relations, then we have understood almost everything in SHM. Right? So have we known this already? Have we discussed this till now? V and x, we already know the relation. Second equation represents this one. X and a, relation between acceleration and displacement, that is already known. Now, relation between v and a. Can we find the relation between v and a? We already found it in the previous session. Right? So let's recollect from the previous session. What did we get? See here. Acceleration is equal to minus omega into root of maximum velocity square minus v square. V is a variable. At different points, at different times, velocity will be changing. That is this v. Vmax is a fixed value. Vmax happens only at the equilibrium, and that is a fixed value. This is variable. These two are variables. As v changes, acceleration also changes. Right. So let's write that relation. Acceleration is equal to minus omega into under root of Vmax square. Maximum velocity is also always a fixed value. Something like a is a constant, no? Something like that. Vmax is also a constant. Minus Vmax square minus V square. And we also know what is Vmax, right? What is Vmax? We got this, no? Vmax is maximum velocity, simply maximum displacement into angular velocity. See, these two, A into omega, we have replaced with Vmax. Maximum velocity is simply maximum displacement multiplied with angular frequency. Maximum displacement possible. If you just multiply with angular frequency, you will get maximum velocity, angular frequency. Maximum displacement, you just multiply with omega, you get maximum velocity. Okay. Okay. Okay, can you tell me when does A become maximum? Anyone? From this equation, can you tell me? A changes as V changes. Can you tell me by looking at that with common sense, just with common sense? You don't need to use any technique. For what value of V, A becomes maximum? As V increases, the subtraction decreases. So as V increases, the acceleration decreases. So what is the best value of V for which A becomes maximum? Just simple substitution. Just look for what value of V it will become maximum. If V is minimum, then when you subtract something, so then you subtract some minimum value, then the total value becomes maximum. So what is the maximum possible acceleration? Acceleration is maximum, well, velocity is minimum. Correct or not? Just think. At the extreme positions, velocity is 0. And at the extreme position only, restoring force is maximum or acceleration is maximum. Force and acceleration, they are like just MA relation, F equal to MA. And F is maximum, A is also maximum. Hope you're following. At what value of velocity acceleration is maximum? Anyone? Minus omega. You can look at this one or this one, anything is fine. Minus omega times V is 0, but just put V equal to 0. This happens when A maximum happens when V becomes 0. Okay. And V maximum happens. When does V maximum happen? When does V maximum happen? See this one. Look at this one. V maximum happens. Vmax happens. Velocity is maximum. Happens when displacement is 0. See this one. If you put x equal to 0, that is when you get maximum velocity. Now, similarly, acceleration is maximum when velocity is 0. Observe carefully. Amax happens when velocity is 0. Simple stuff. So omega into maximum velocity. And what is maximum velocity? Maximum velocity is just A into omega. So A max is equal to minus omega square into A. So maximum displacement, using maximum displacement, we can get maximum velocity and maximum acceleration. They are very simple. See, maximum velocity is related to maximum displacement. Maximum acceleration is also related to maximum displacement. And they're just related to maximum displacement with the help of just omega or omega square. Simple stuff. We have not got anything from out of the box. Whatever we have derived in the previous session, I've asked you to derive it once again on your own. Very simple derivations only. From that only, we're just putting some values. V equal to 0, we're putting x equal to 0. And we are trying to understand maximum value of acceleration, maximum value of velocity. Okay. Right. So I'm moving to the next slide. We are discussing something. So okay. We're talking about relation between acceleration and velocity. We're discussing about relation between acceleration and velocity. Okay. So we got the relation between acceleration and velocity. Okay. We know what is Vmax, what is Amax. Okay. So can you tell me quickly, in the previous slide we have discussed, can anyone tell me what is Vmax and Amax? Anyone?
Vmax is A omega,
omega.
A max equal to A omega.
Omega square.
Excellent.
Omega.
Maximum displacement times angular frequency. What is maximum acceleration? Maximum displacement times omega square. Just omega. Instead of omega, it is omega square. There is a minus sign extra.
Minus.
Okay, since we are talking about only about magnitude, you can just remove that minus sign. That's okay. You can ignore that minus sign because we are just talking about magnitude. Okay, right. Or we can also write it as omega times maximum velocity. If you know maximum velocity, just multiply with omega. If you know maximum velocity, just multiply with omega to get maximum acceleration. If you know maximum velocity, just divide with omega to get maximum displacement. Simple stuff, simple relations. Okay, very good. Next, fourth point, fourth relation. We have talked about these three relations. These three relations are done. Next, x and t. What is the relation between x and t? Displacement and time. We've derived it, right? X equal to displacement is a sine of omega t plus phi. I'll just show you. See here, yesterday we've discussed, we've derived it here. See, a sine omega t plus phi. What is omega? Root of k by m. Correct? So this is the relation between displacement and time. Since x is displacement, it is a function of time. It is changing with time. So the simplest notation is just x, but the better way of the notation, a better notation would be instead of x, you just write it as, you can write it as instead of x, you can write it as x of t, or if there's somebody writes it as just x also, that is fine. But x of t is more appropriate. You might have learned about functions a little bit, no? F of x. When a function f changes with respect to variable x, we write it as f of x. That is a very good notation. Since x is displacement, displacement is a variable, it changes with time, it varies with time. Since it's a function of time, it changes with time, we write it as x of t. If you want, you can just write it as just x also, x equal to a sine omega t plus phi. But somebody writes it as a sine omega t plus phi means, you can also write it as a cos omega t plus phi also, no problem. There is no issue in that. You can also, whenever you write it as a sine omega t plus phi, you can write as a cos omega t plus some phi dash, something like that. Or what is the relation between cos and sine? What is the relation between cos and sine? Cos, if you shift it towards the right side, cos, if you shift it towards right side, see, remember, cos is gonna look like this. Maximum at 0, cos 0 is 1, right? And sine is gonna look like this. It starts from 0. This is sine theta. This is cos theta as a function of theta. This is how they look like. Very simple. Look, the graphs are looking exactly same. Only thing is the vertical line is at different places. Vertical line here for sine theta starts at when the sine theta is 0. Vertical line for cos theta starts at maximum value of cos theta. Okay. So now look at this one. Cos theta, can I write it as sine of theta minus pi by 2? Is that okay? Sine of theta minus pi by 2. From the graph I'm telling. So you might have learned about sine of theta minus pi by 2, sine of theta plus pi by 2, something like that. So whenever you do subtraction inside the angle, what happens is the total graph shifts towards the right side. See this one, this graph, sorry, sine of theta, no, wrong, my mistake. Sine of theta plus pi by 2. Yeah, sine of theta, whenever you do theta minus pi by 2, it's like shifting towards the right side. Whenever you do theta plus, it is shifting towards left side. See this one, sine graph shifted towards left side by pi by 2. See this one, this is pi by 2. When you shift this graph towards left side by pi by 2, what happens? This maximum point comes onto the vertical line. So it looks exactly like cos. Similarly, if you want sine in terms of cos theta, you just need to shift it towards the right side by pi by 2. Right side by pi by 2 to look it like sine. So cos you can write as cos of theta minus pi by 2. Okay. So, or whatever basics you learned of trigonometry, if you know the relation between sine theta and cos theta, if you can express it like this, then you can do it in your own way, or you can follow my method. Whenever there is minus sign, it's like shifting towards right side. Whenever there is a plus sign, it's like shifting towards left side. Okay, or I'll tell you an easier way. Remember only this much. Okay, remember only one point. From that you can get everything else. Remember only one point. Sine of theta plus pi by 2. Whenever you add or subtract pi by 2, whenever you add or subtract pi by 2 for sine or cos, what happens? You get the other one. Theta plus pi by 2. Whenever you shift, see this one? Whenever you shift it by pi by 2, this side or that side, whenever you shift sine, this side or that side by pi by 2, it looks like cos or minus cos. Only there are two possibilities. It is definite sine. When you shift it by pi by 2 this way or that way, it is definitely cos. But the question is whether it is cos or minus cos. That is the only question. So sine of theta plus pi by 2. Remember, sine of theta plus pi by 2 means sine theta shifted towards the left side. It is going to look like cos. So if you're not comfortable with graphs, forget about them, no problem. So only remember this much. Only remember this. Only remember this. Okay. Now tell me this. If sine of theta plus pi by 2 is cos theta, what would be sine of theta minus pi by 2? See this one, sine, when you shift it to with pi by 2, that side or this side, it will definitely become cos. But since you remember the first one, you remember it as plus. If you take plus here, it is cos theta. If you take minus here, then definitely these two are not same. So it should be minus cos theta. That is the easiest way to remember. Next, similarly, cos of theta plus pi by 2. Cos of theta plus pi by 2. Sine of theta plus pi by 2 is cos. Cos of theta plus pi by 2. Cos, when you shift it towards right side or left side by pi by 2, it should be definitely sine. But the question is whether there is a minus sign or not. Will there be minus sign? When sine is added with pi by 2, there is no minus sign, which means whenever you do it for cos, it will be opposite. So there should be a minus sign. If you do plus pi by 2 for sine, there is no minus sign. When you do it for cos, it will be just opposite. There will be minus sign. Similarly, cos of theta minus pi by 2. Since there is, when you shift it by plus or minus pi by 2, it will definitely become sine. But the question is there is a minus sign or not. When you do plus pi by 2, there is minus sign here. So when you do minus sign, there should be plus sign. This is one way of remembering this. From this, you can get all the remaining four. If you're not comfortable with graphs, then I would suggest you to remember the first one, and from that you can get the remaining three. Write them on your own so that it will be easy. Similarly, you can do other stuff also. Okay, cos of, somebody says cos of theta minus 3 pi by 2. Don't remember anything for 3 pi by 2. Okay, 3 pi by 2, can you write it as minus 3 pi by 2? What is minus 3 pi by 2? Minus 3 pi by 2 is same as plus pi by 2, no? 3 pi by 2 in anti-clockwise direction is same as minus pi by 2 in anti-clock. 3 pi by 2 in clock is same as pi by minus 3 pi by 2 in clockwise direction is same as pi by 2 in anti-clockwise direction. Generally, we measure angle in anti-clockwise direction. Okay, we measure angle in anti-clockwise direction. Okay, so if it is positive angle, it will measure in anti-clockwise. If we measure it in negative side, I mean, if there is a minus sign, it is measured in clockwise direction. This one, minus 3 pi by 2 means there is a minus sign, so measure it clockwise. Generally, we measure angle in anti-clockwise if it is positive. So this is the point that you're talking about. If you want to reach this point, either you can travel minus 3 pi by 2 clockwise, or you can also travel plus pi by 2. Both are same, no? So you can write theta minus 3 pi by 2 as theta plus pi by 2. Okay, whenever you see 3 pi by 2s, just convert them into pi by 2s. Then it will become easy. So cos of theta plus pi by 2. We know sine of theta plus pi by 2 is cos theta. Cos of theta plus, same angle, but here it is cos. Cos, when you shift it to plus or minus pi by 2, it becomes sine. Because it is plus sign here, it should be minus. Okay. Okay, fine. So I hope you are able to remember a few things here. Okay. In some other future classes, I'll take a session on this trigonometry things if you are confused. Definitely trigonometry is a little bit confusing if you have not worked on it. So I'll take some session on based on this, if at all, if you're still having confusions in some other time. Okay. So can we write this a sine omega t plus phi as a cos sine? How can we write sine theta? How can we write in terms of cos of whatever is inside, whatever is the same angle, just subtract minus pi by 2. Cos of omega t plus phi minus pi by 2. Okay, which we can write it as a cos omega t plus some phi 1. Can we say that phi minus pi by 2? I'm just writing it as some phi 1. So the point I want to make finally here is, okay, the discussion that we have done for the last 10 minutes is about the understanding of cos and sine and the relation between them. Okay, yeah, let's keep the discussion about relation between sine and cos. Let's put that aside. And the final point of why I have derived it is x of t, we have derived it as a sine omega t plus phi, but it is also same as a cos omega t plus some phi, some other phase. The phase will not be same. When you write sine in terms of cos, the phase part will not be same exactly. It will be different. If you go back, see this one. Differentiation of sine inverse of x by a is 1 by root of a square minus x square. Okay. Now differentiation of cos inverse of x by a also we can find, and that is minus 1 by root of a square minus x square. The result is same. If you integrate this one, you get a similar result, right? So that's why you don't think that there should be only sine only, x equal to a sine omega t plus phi. No, not required. You can write it as a cos omega t plus phi also. A cos omega t plus phi also you can write. Okay, I hope you're following. You might think that that minus sign is there extra. Okay, minus sign I'll send it inside as phase. Minus sign I can write it as sine theta minus sine theta. Can we write it as minus sine theta? Can we not write it as sine of theta plus phi? We can write it. So we can send it as phase. That minus sign we can send it as phase like that. So instead of sine omega t plus phi, you can also write it as cos omega t plus phi. Okay. Cos and sine both are sinusoidal signals. So the relation between displacement and time is sinusoidal. Sinusoidal means that curve, that whatever curve you are seeing, cycles curve. So that is the relation between displacement and time. Now quickly tell me, what is the relation between velocity and time? Velocity, v, just differentiation of x of t, we get it. We can write it as v equal to a times, if you differentiate sine, you get a omega into sine into cos of, the sine differentiation is cos of omega t plus phi. So if you take this one, if you take cos, then you differentiate. If displacement is written as cos, then velocity can be written as a sine of a omega sine of omega t plus phi. Okay, you can differentiate this also, but let's take this one and try to find the velocity, because when you write cos, you can also express it in terms of sine of omega t plus phi minus pi by 2, something like this. So since velocity is also a function of time, I'm writing it as a function of time. Instead of v, I'm just writing it as v of t. Whenever you see in a questions v or just v or v of t, both are representing the same thing. So this one we got a relation between vt also. Next, differentiate once again. Velocity, you just differentiate once again, you get acceleration. What is acceleration? So differentiation of cos, differentiation of velocity will give you acceleration, and it will be minus cos. The cos differentiation is minus sine minus sine and differentiation of inside part, omega will come outside. It will be minus omega square sine of omega t plus phi is the differentiation of v of t. Since acceleration is also a function of time, so it's okay to represent it as just a or a of t. Okay, so we can write acceleration as a function of time. If you observe, you just take minus omega square aside. What it looks like is, if you remove minus omega square, what remains is a sine omega t plus phi, which is same as x of t, minus omega square into x of t. This is the basics of, this is the very basic from which we have started this discussion. Acceleration equal to minus omega square times displacement. So we got all the 6 relations. We got all the 6 relations, wonderful relations. You can get them on your own. You can get them on your own. You don't need to by heart them. You don't need to by heart them. Understand the flow with which we have created them. Okay. If you by heart them, you'll forget after a month. If you understand, so everything we got it from this only. Everything we got it from here. So have the confidence that I can derive. If I forget, I can derive from this. Do we need to derive every time? Every time? Not required. Most of the things we remember. Okay. If at all, if we have confusion or if we forget, then we have a source. If you're confident, you can hardly derive in a half minute or 1 minute. Okay. Once we solve the precautions, we will remember most of the things. Okay. We don't need to specifically put effort to remember them. Okay, fine. I hope it is clear till this point. Any confusions till now? Anyone wants me to explain anything particular? Harsha, Rishika.
Sir, can you repeat that fourth part?
Which one? Fourth point, huh?
Yes.
Which mean, you mean the sine and cos relation?
Yes, sir.
Very good. Okay. So let me try to explain in a different way. You mean this part, left side part, or this part, the curve part?
This part only, sir, not the left.
On the left part, okay?
Yes.
Here I've just told you a technique. Just to convert, when you want to convert sine into cos, express sine in terms of cos or cos in terms of sine, in that situation, what is the easiest way to remember? This technique I have given only for people who are not at all comfortable with trigonometry. Okay, for them just to blindly remember it, I have given something like that. Okay, okay, or else I'll tell you a much more easier technique. Let's try one more easier technique. Okay. Let's take the help of substitution to get it. To understand this, you should be knowing the values of sine and cos for at least 0 to pi. If you know the values of sine and cos from 0 to pi, yes, we can construct this relation. Now, don't look at this one. Don't look at this one. Just sine, when you add it with plus or minus pi by 2, when you add or subtract with plus or minus pi by 2, when you add the angle, basic angle with plus or minus pi by 2, definitely you will be getting cos. That much, is that part clear? Or
Yes.
you can look at from here. When you are adding pi by 2 means, okay, sine of, you're talking about this angle. You're talking about this angle. Let's say this is theta. The value of sine of theta, it's not sine theta, okay? We're talking about sine of theta plus pi by 2. Sine theta means this value. Theta plus pi by 2 means it is this value. This is theta plus pi by 2. Right? Sine of theta plus pi by 2 is this value. This value, if you map it onto cos, the gap between cos and sine is pi by 2, correct? If you shift pi by 2, you get cos. See here. If you say sine theta, if you shift it towards left side by pi by 2, you get cos. Or cos, if you shift it towards right side by pi by 2, you get the graph of sine. So this value, this exact value is here. Correct? Now
Yes,
tell
sir.
me, what is the angle here at which cos theta will have the same amplitude? Theta only, no?
Yes.
Theta plus pi by 2, whatever amplitude is there for sine, same amplitude is there for cos. That is what we are trying to write here. Sine of theta plus pi by 2. Sine of theta plus pi by 2 is some value, no? Sine function height at some theta plus pi by 2 angle. That angle, that height, that amplitude, sine amplitude at this angle is same as cos amplitude at theta. That is what we're trying to say. Sine's height at theta plus pi by 2, is same as the same height you're seeing in cos at theta angle. Okay, fine. Now, so whenever you shift pi by 2, plus pi by 2 or minus pi by 2, whenever you do, Sine becomes cos or cos becomes sine, or sine can be looked at as cos or cos can be looked at as sine. Now tell me this. If you are confused, if you forgot this also, no problem. We can use our basics to get it back. And what is that basic? Let's substitute some values. No? Can you substitute some value here? Shall we substitute theta equal to 0? Substitute theta equal to 0 and see. Sine, when you add it with plus or minus pi by 2, it will definitely become cos. That is for sure. But there is a minus sign or not? That is the only question. Sine becomes cos, cos becomes sine when you add or subtract with plus pi by 2. Okay, the question is that there is a minus sign or not. That is the only question. Sine becomes cos when there is a plus or minus pi by 2. Now tell me this. We put theta equal to 0. Theta equal to 0 on both sides. Now it becomes sine of 0 plus pi by 2. What is it? 1 only, no?
Yes, sir.
Cos of 0 is also 1. Matching, no?
Yes, sir.
Perfect. So there's a plus sign. Now, sine of, you don't need to by heart all this. Sine of theta minus pi by 2. When there is pi by 2, sine of angle minus pi by 2, that angle, you just write it with cos. Simple. Sine becomes cos when you add or minus subtract with pi by 2. But the question is whether there is a minus sign or not. Let's substitute 0 and see. Let's substitute 0 on both sides and see.
It will be -1.
Sine of minus pi by 2, now it becomes, when you substitute theta equals 0, sine of minus pi by 2 is -1, whereas cos of 0 is 1. They're not equal. They'll become equal only when you put a minus sign here. Now it becomes easy.
Yes.
Very good. Similarly, can you try for cos also?
Yes, sir.
Yeah, let's try for cos also. You do it along with me. Cos of theta plus pi by 2. When there is a pi by 2, addition to original angle is theta, you have added plus or minus pi by 2, then you can express it as sine of the original angle. But the question is, there is a minus sign or not? So now substitute 0 here, 0 here, sine 0 is 0, cos pi by 2 is also
0.
0. But 0 minus sign is there or not? We can't figure out with 0, no? Whether it is
Yes.
minus 0 or plus 0, both are equal, no? With 0, we can't figure out. So try some other value. With 0, we can't figure out. Try some other value. Shall we try pi by 2?
Okay.
Because when you substitute zeros, no, if you will not get something like -0, no. The idea here is whether there is a minus sign here or not. That is the question. When you get both sides zeros, if there is a minus sign or not, then both ways relation will be satisfied. No, whether it is a plus relation or minus relation, both will be satisfied. So don't substitute a value so that you get 0 on both sides. Because when you substitute, you feel like that is correct only. Okay, right. So for example, what I'm trying to convey here is, so what about sine of theta minus pi by 2? That is also sine theta, but there is a minus sign or not, that is the question. So put 0 here and 0 here, then also it is satisfied, no? So cos of theta plus pi by 2, cos of theta minus pi by 2, both can't be sine theta. One of them should be minus sine theta, right? So let us substitute some other value. Let us substitute some other value, not 0. 0 is not the right value for this. What shall we substitute? Let's substitute pi by 2. Theta substitute with pi by 2. What is this side? Sin theta is 1, sin pi by 2 is 1. And this one is cos of theta, in place of theta, it is pi by 2. Pi by 2 plus pi by 2 is pi. Cos pi is how much? -1. On the left hand side, we got -1. On the right hand side, we got +1. So the relation is not satisfied. When will the relation be satisfied? There should be a minus sign extra. Okay. Similarly, you can do the same substitution here also. Theta in place of theta, pi by 2. Pi by 2 here, pi by 2 here. Sin theta, sin pi by 2 is 1. Sin pi by 2 is 1. So cos of pi by 2 minus pi by 2
Also 1.
is also 1. Satisfied, no? So there
Yes.
is a sign. Is this easy?
Yes, sir.
Okay, very good. Fine. Okay. Similarly, you can try for plus pi also. When you add with pi or multiply, add with pi or subtract with pi, what is the meaning of it? Shifting. When you shift this graph by pi towards the other side, what happens? You'll get the minus of that graph, no? See this one, this graph, if you shift it by pi, what happens? If you shift this by pi towards right side, if you shift it,
Also,
then what happens? You get this graph.
then it will be new.
This graph and this graph, they are related, no? They are related with a minus sign.
Yes.
Similarly, if you shift this graph towards left side, then also you get the same thing. Okay, I'm not plotting the remaining part, but you get the same thing when you shift this one towards left side or right side by pi. So sine of theta plus or minus pi is minus sine theta. Sine will become sine only when you add or subtract with pi, but that will become minus pi, minus sine. Similarly, cos also, cos of theta plus or minus pi will be always equal to minus cos theta. Simple. When there is a shift by pi, one half cycle will get shifted, no? So that's why it becomes sine. When sine becomes sine only when half cycle is shifted. Pi means half cycle. See this one. This value angle is pi. When you shift it by pi, half cycle gets shifted. When you shift by pi by 2, what happens? Only 1/4 of the cycle gets shifted. See this one. This is 1/4 of the cycle. This length of this is pi by 2. When you shift this sinusoidal waveform, this waveform or this waveform by pi by 2, then it is matching with cos. Cos, if you shift by pi by 2, then it will match with either sine or minus sine. Okay, the difference in angle, the difference in phase between sine and cos is pi by 2. That's why when you shift the angle by pi by 2 towards left or towards right, it is going to look like cos. Okay, I believe it is clear till this point.
Yes, sir. Understood.
Yes, sir.
Good. Next. So we have just till now what we have done is we have put everything that we have discussed in the last 2 sessions in one place. Okay. So try to revise all this, try to write everything that we have written on this slide on your own. Okay. When you forget, you can just look it back, but try to figure it, write it everything on your own. They're easy things. Don't buy heart. Never buy heart. If you buy heart, it is done. You're not following the right path. Right. Next one. So we have given you some questions here. The question is, I have given you displacement versus time relation. For the following, displacement versus time graphs, time equations. Find if they are following simple harmonic motion. Are they following simple harmonic motion or not? That is the question. You know the basic of SHM. When can you say that SHM is being followed? Simple harmonic motion is a special type of oscillation where the acceleration is proportional to displacement or force is proportional to displacement, right? So if you want SHM condition, what is the condition for SHM? Condition for SHM is you can find acceleration because displacement is given. From displacement, you can find acceleration. Acceleration should be equal to minus omega square times displacement. This relation should be satisfied if any displacement is satisfying SHM, it should satisfy this equation. Okay. Why I have written only A is equal to minus omega square x, not F equal to minus k times x. F equal to minus k times x, you can write it, but force we can't find from here. No, we can find force also, but mass and all that are not involved. Displacement is given. From displacement, we can find acceleration. So just try and apply this equation. If this equation is being satisfied by each problem or not, just check. If it is satisfying, it is SHM. Otherwise, it is not. First one. dy by dt. Don't worry, I have taken x as the notation for displacement. In this problem, they have taken y as the notation. That's fine. Any notation is okay. dy by dt, just differentiate it and see. A into e power j omega t, sorry, I is the notation that used in intermediate, I omega t into differentiation of the power is I omega. Now we don't want velocity. This is velocity. We want acceleration. Acceleration is differentiation of velocity or double differentiation of displacement, which is a into differentiation of this is again e power I omega t into I omega is already there. Because of again differentiation, another I omega will come. Another I omega will come. I omega square. See this one? Earlier already this part, if you differentiate it, another I omega will come. So is it not looking like omega square outside? I square is -1. Are you aware of this part? I is equal to root of -1 and I square is -1. We call it as complex. In complex numbers, we use this letter called I. Okay. Whenever they use I letter in mathematics, they mean, what they mean is I is a root of -1. We call it as complex number. So look at this one. I square is -1. Omega square is there into a into e power I omega t. This is minus omega square into y. Is it satisfying the relation?
Yes, sir.
It is satisfying the relation. And one more thing is, have you heard of this? E power ix. Can we write it as cos x plus I sin x? Do you know this? Are you aware of this basic?
No, sir.
Okay, you are not aware of this. Okay, fine. E power, when there is in the power, if there is I, then you can write it as cos x plus I sin x. Okay, so e power ix function has internally, if you expand it, you're having cos x and you're having sin x, both of them. So e power I, whenever in the power there is I, then it's like a sinusoidal function only. We call it as complex sinusoidal function. There are sinusoids inside e power ix. Complex sinusoids. Call it as a complex sinusoidal function. Okay, right. So this a into e power j omega t, can we write it as a cos omega t plus I times a sin omega t? Can we write it like this? It is sinusoidal. Is the displacement sinusoidal? Yes, no? We'll discuss more about this later also. We'll come across this items in future classes also. I'll be using it in some chapters also. We'll get used to it. This is the first time I'm introducing, so it might be looking very new for right now, but don't worry. As we go further, we'll be using it again and again. Then you'll become comfortable with it. Okay. Right. See this one? A equal to minus omega square y. This is satisfied. Perfect. And it is also sinusoidal. Displacement should be sinusoidal. Yes. So that's hence this is satisfying. Hence, whatever equation is given is it is SHM. It is satisfying simple harmonic motion. How about the next one? See here, e power x, that cannot be written as cos x plus j I sin x. We can't write it like this. When there is no I in the power, and there is no I in the power, we can't write it like this. We can't write like this. Only when there is I, that is when we can write like this. See, cos and sin means they look like this. Sin looks like this. Sin looks like this. Okay. So e power x cos, you know how it looks like. It is a just shifted version of sin. So combination of cos and sin with the letter I, if you add them, it becomes some kind of complex signal. Because of this complex number I, it becomes a complex signal. Whereas e power x is not like that. E power x is different. E power x is different. Its graph is something like this. Its graph will be something like this. If you plot e power x, it is gonna look something like this. If you plot e power minus x, it is gonna look something like this. Decreasing function or increasing function. That is how it looks like. The same exponential function When you have I, it is going to look like this. This function added with this function multiply with sine x. You multiply with I, and then it is cos x. Cos x mean, it looks like this. You can add these two with multiply after multiplying with I. That is how e power ix looks like. The combination of these two is how e power ix looks like. But e power x without I, this is how it looks like. If there is a minus n, it will be decreasing. Okay, fine. So let's do the second question. Dy by dx, simple differentiation. Just try to find the acceleration. Just try to find the acceleration. See the relation between acceleration and displacement. It is a into e power minus omega t. If you differentiate it, it becomes minus omega. And d square y by dt square is minus omega whole square. Minus omega whole square into a into e power omega t minus omega t. See this one, minus omega again will come. So it becomes plus omega square into a into e power minus omega t. So is the relation satisfied? The minus sign is missing. One reason is minus sign is missing. Acceleration and displacement. This is equal to omega square into y. So acceleration is proportional to displacement, but the sign, the direction of displacement and acceleration in this case, both are in the same direction. That is one reason to say that it is not SHM. That is one reason to say that it is not SHM. And one more reason is in SHM, the displacement, velocity, acceleration, how do they change with time? How do they change with time? Just go back to the previous slide and see. How do they change with time? Displacement, velocity, acceleration. If you plot a graph of displacement, velocity, or acceleration with respect to time, how do they look like? How do they look like? They are sinusoidal signals, no? They're sinusoidal functions. They look like sinusoidal functions. I hope you know how we got this result from the very basic, a equal to minus omega square x. From this only we got this result, right? So whenever you're talking about SHM, displacement, velocity, or acceleration, they always should be a sinusoidal graphs. Sinusoidal means it can be cos or sine, it can be anything, but it should be sinusoidal graphs. I'll show you some other slide also, and you'll understand it better. See this one? Displacement versus time graph. This is how it looks. If it looks like this, then velocity versus time graph. This is how it looks like. So if you remember our equation, x equal to a sine omega t plus phi, no? That phi I'm taking it as 0 and plotting. Just take phi equal to 0 and plot it. If phi is 0, then only you can plot it like this. Then v equal to a omega cos of omega t plus phi. I'm taking phi as 0. Because if you don't take phi, what is some value for phi, you can't plot it exactly. You should know the value of phi. The phase part, phi, I'm taking it as 0 just for easiness of plotting. If you take phi as 0, it is cos omega t. You know how cos omega t looks like. At 0, it becomes maximum. At 0, it is maximum. Okay. Next acceleration is minus a omega square into sine of omega t plus phi. I'm taking phi as 0. So look at this one. This is minus omega square extra, and it is looking like x. See this? Is it correct? How x looks like? There is a minus sign extra. See this one? There is a minus sign extra. Whenever it is plus 1, this is becoming minus 1. See? Whenever it is plus 1, this is whenever x is plus 1. Whenever x is plus 1, what is this becoming? This is minus omega square into plus 1. Whenever it is becoming positive peak, it is having negative peak. Acceleration is negative maximum. Whenever displacement is positive maximum, acceleration is, since it is having opposite sign. See, this is increasing. Acceleration is also increasing, but with opposite sign. Okay. Hope you're following. The graph of displacement, velocity, and acceleration should always be sinusoidal for the motion to be simple harmonic. If it is not sinusoidal, if you draw the graph of displacement versus time, or velocity versus time, or acceleration versus time, one of them, if it is not having this one of these shapes, sinusoidal shapes, these cycle shapes, then it is not SHM. That motion is not SHM. That motion might be oscillating motion, but it is not simple harmonic motion. Okay. Did you understand this point?
Yes, sir.
I hope you're following what I
Yes,
mean by
sir.
sinusoidal. Sinusoidal means this kind of curve, this kind of graph. This vertical line can be anywhere. This vertical line can be anywhere. We can call it a sinusoidal function. Okay. This vertical line, particularly if you take here, if you take it here, you can write it as a cos omega t plus 0. If you take that vertical line here, you can write it as a sin omega t plus 0. That phi, if you take some other values, then this vertical line position will change. Vertical line represents 0 position, time 0. The starting time at which you are observing, that position will change as a function of time. This is how a cos omega t plus phi or a sin omega t plus phi looks like. Okay. This is time 0. At time 0, what is the amplitude? Okay. Right. Don't worry. We'll discuss a lot. Many times we'll repeat these graphs. So as we go along, you'll understand it clearly. If at all, if there are any and not any clarity missing about the sinusoidal graphs, you'll get the understanding very well as we progress. So can anyone tell me what is the height here? Anyone? See this one, this mathematical equation I've plotted. Anyone? See sine with the time, the angle changes. With sine, if you look at this as simply a sine theta, okay, this theta, as theta changes, sine theta value also changes. How does theta change? Theta is omega t plus phi. As time changes, theta also changes. As theta changes, sine theta changes. With time, theta changes. See time? With time, as t increases, theta also increases. As time increases, theta also increases. Sine theta, what happens to as theta increases? Sine theta also increases initially, no? From 0 to pi by 2. Sine theta also increases. Sine 0, we know 0. Sine pi by 2. Sine pi by 4 is 1 by root 2. Sine pi by 2 is 1. Correct? It is increasing, no? When is it maximum? Very simple stuff. Sine theta, what is the maximum value of sine theta? Whatever is inside sine theta, you can put any garbage that you want inside sine. You can put any garbage, whatever you want to put. What is the maximum value possible? What is the maximum value of sine theta or cos theta possible? Any garbage you put inside cos or sine, the maximum possible value for sine or cos is 1. You don't need to by heart this, okay? You know about cos and sine, no? You might have learned in 10th class. What is cos 0? 1. Cos pi by 2, 0. Cos pi is minus 1. So what are the possible values for cos? From minus 1 till plus 1. Only those values it will take. From minus 1 to plus 1, any value it can take based on the angle. Cos pi by 4 is 1 by root 2. Okay, cos minus pi by 4 is also 1 by root 2. Right? So if you take any value of cos or any value of sine is always in the range minus 1 to plus 1. The max value possible for cos or sine is plus 1. For some angle, it will become plus 1. Okay. So what is the maximum value possible for sine? What is the maximum value possible for sine of omega t plus 1? Whatever is inside sine, that is, it doesn't matter for us. Sine means its maximum value possible is 1. So what is the maximum value possible? What is the maximum height possible here? What is this height? Can anyone tell me? When sine becomes plus 1, that is the maximum value possible for sine. When sine becomes plus 1, x becomes maximum. And what is that value of x? A. Similarly, can somebody tell me what is the minimum value of sine? What is the minimum value of sine? Sine or cos? Sine or cos? Sine theta takes values from minus 1 to plus 1. It takes values from minus 1 to plus 1. Similarly, cos theta also takes the same range of values. Okay, right. What is the minimum value possible? This negative value, the negative maximum or the minimum value happens when sine theta becomes minus 1. When sine of omega t plus phi becomes minus 1 into a becomes minus 1. Whatever you are seeing beside sine, right? That itself is the maximum amplitude. Very simple stuff. Cos and sine. Before cos and sine, whatever is the number multiplied, that will tell you the height, the maximum height of that graph. And if you apply minus sign to that number, you'll get the minimum amplitude. You get the maximum, minimum, or maximum, positive maximum, negative maximum. Simple stuff. Now, since you have understood this first graph, how about the second graph? Can anyone tell me about the second graph?
Maximum A omega.
Excellent. See, cos, whatever is inside cos, it doesn't matter for us. Cos maximally possible is 1. So the maximum happens for V, velocity, when this cos becomes plus 1. When cos becomes plus 1, what do we get? We get A omega. A omega. And what is the minimum?
Minus A omega.
Very good. Minus A omega. Now, can anybody try this one? Try this one. Acceleration, minimum and maximum.
Max is A omega square.
Very good. What is the
And
maximum?
minimum A omega square.
Harsha, can you tell me the minimum?
Minus A omega.
Minus A omega square.
Harsha is sleeping.
Sir, can you explain second graph again, sir?
This one, right? You mean the maximum value?
Yes, sir.
Purnashri, right? Okay. See, when cos becomes plus 1, cos can take plus 1. Plus 1 is the maximum value that it can take. When it takes plus 1, at some time it will take. We'll talk about that, how we can find that time also. At what time it becomes maximum also we can find that. We will discuss about in other sessions. For now, our target is this sinusoidal graphs will have some maximum, some minimum, some maximum, some minimum. At some places it becomes maximum. At some places it becomes minimum. At these places, whenever it takes maximum, at these places, it happens at some times, at some time t1, at some time t2, sometimes it will happen to be maximum. At all these times, you have cos taking plus 1 value. So the height here is A, the height here is A, because cos is taking plus 1. Similarly, at these values, at these positions, cos is taking the least value possible. And what is the least value possible for cos? Least value possible for cos is minus 1, right? So at this position, cos is taking minus 1, and hence the amplitude is minus A. Whatever is written beside cos, whatever is the number written beside cos, that will decide the maximum amplitude, minimum amplitude. What is written beside cos? Tell me. When cos becomes plus 1, what is the value of velocity? A omega into 1. A omega into maximum value of cos is 1. That will give you the maximum velocity. V max. From this graph also we can find what is V max. V max happens when A into omega into cos is the variable. A and omega are constants. When cos of omega t plus phi, that becomes maximum. That becomes maximum. When this becomes maximum, that is when we get velocity maximum. And what is the maximum value of cos? See, cos theta, sin theta, they take values from minus 1 to plus 1. They take values from minus 1 to plus 1. Minus 1 is the least value, plus 1 is the highest value possible for cos or sin. So the highest value possible for cos is plus 1. You get the maximum velocity as A omega. Maximum velocity here, maximum velocity here, and at many places it happens. It happens at many places. Here also it will become same thing. And how about here? Similarly, if you want minimum or negative maximum velocity, put in place of cos, put the least value possible. What is the least value possible? Minus 1. Put minus 1. You get A omega into minus 1. That is what you get here.
Minus omega.
Following?
Yes, sir.
So, okay, I'll ask you one question just to test if you have understood it or not. 10 into 20 into sine of omega t plus pi by 2 plus pi by 4. So can you tell me what is the maximum amplitude possible for this signal? Can you? I'm just trying to confuse you. Don't get confused. What is the inside angle? It doesn't matter, no? When you're talking about maximum or minimum.
200, sir.
Don't worry about the inside part. Don't take total sine thing.
200.
Very good. Sine function, whatever is inside that, you should not fear about when you're talking about maximum and minimum. Okay, when you're talking about sine amplitude at some time, at a particular time, if you want, at some time t equal to 1 second, if you want to analyze, yes, these angles also will be important, pi by 2, pi by 4 also. But when you're talking about maximum, minimum, it just take the sine function, just replace it with plus 1, replace it with plus 1. If you replace sine value with +1, that means you're trying to find the maximum value. 10 into 20 into +1. Simple. What is the minimum value?
Minus 200.
Excellent. That's it. Whatever is written beside cos or sine, that will give you the peak value, highest value. And similarly, the lowest value also. Very good. So I hope everybody has understood that displacement, velocity, and acceleration, they vary sinusoidally in a simple harmonic motion. If it is not simple harmonic motion, then they need not vary sinusoidally, but in simple harmonic motion, they will definitely vary as a sinusoidal function with respect to time. Okay, so here there are two things. It is not sinusoidal. How do you say that it is not sinusoidal? Because we know some basics here about exponential functions. See here, exponential function can be of two types, with I, without I. With I function, it is always sinusoidal. It is a combination of sinusoidal functions. Without I means we call it as only exponential functions. It is going to increase or decrease exponentially, something like this. Without I, it is not sinusoidal. It is not sinusoidal. If it is not sinusoidal, by directly looking at it itself, without doing all this, you can just decide that it is not SHM. Okay. But if you don't know about the sinusoidal stuff, whatever I've discussed previously, but because of the minus sign also, you can decide that it is not SHM. But the main reason is it is not sinusoidal, first of all. Right? Can I move to the next one? Any questions till this point?
No, sir.
No, sir. Understood.
Okay, good. Next one. Can you quickly do this one? Sine square theta. 2 sine square theta, you can write it as 1 minus cos 2 theta. Right? If at all, if I'm writing anything behind my my video, just let me know. Similarly, 2 cos square theta is 1 plus cos 2 theta. Can we write sine square? Sine square, yes, sine function is there, but we have not discussed it as sine square or something like that, right? Okay. Okay, whatever idea you get, okay, any idea is fine, okay, any idea is fine. Don't think that you should apply only this idea or that idea. That there is no rule like that. You have to apply the basic. The basic is it satisfying that relation, SHM relation or not? That is the idea, right? Let's find it. dy by dt. If you know how to differentiate this, then directly you can go ahead. Is 2a into sine square can be written as 2 sine omega t into differentiation of sine is cos omega t into omega. If you're not comfortable with squaring, if there is squaring, if you don't know how to differentiate, then it's better you write it as without squaring, something like this, and then differentiate. Both are fine. So if you want, you can write as a sine square. I'm writing it as 1 minus cos of 2 omega t divided by 2. If you're comfortable with differentiating this, that is also fine. If you know how to differentiate this, then change it into a format which you are comfortable to differentiate. Okay, if you can differentiate directly, yes, differentiate it directly. Or else you can do it this way. You can convert into a form that you're comfortable with to differentiate and then differentiate. Okay, so you can write it as a by 2 into differentiation of 1 is 0 minus cos 2 omega t differentiation is cos differentiation is minus sine. So it becomes plus sine 2 omega t into 2 omega. See this one? 2 sine omega t cos omega t is nothing but sine 2 omega t. Correct? Into omega. See this one, 2 and 2 can cancel. Are we getting the same result or not? Both ways. A sine 2 omega t into omega, a sine 2 omega t into omega. Same result, no? So don't worry, whatever idea you get, it doesn't matter. Any idea, as long as you do it correctly, you'll get the final same answer. Don't worry that you should get this idea or that idea. Any idea will work. Okay, so we got dy by dt. But what do we want? We want relation between acceleration and displacement. Based on that, that is the easiest way to Tell. So d square y by dt square. This is velocity and this is acceleration, which is a into omega, that is constants. Sign differentiation is cos 2 omega t into minus 2 omega. Okay, so how do we express this? Minus 2 omega square into a into cos 2 omega t. So we have to express it in terms of y, some constant terms y. We want a relation between acceleration and displacement. So try to relate this with the displacement. The displacement relation is looking like sine square omega t or 1 minus cos 2 omega t, no? So are you able to express it in terms of displacement? Are we able to express? Let's try to express, okay? If you want to say whether it is SHM or not, you should know the relation between acceleration and displacement. So instead of cos, you should write something like y. If you can express this equation in terms of y, then you'll get the relation between a and y. Right? You know what is cos 2 theta? Cos 2 theta, let's try to express it in terms of sine. See, cos 2 theta. How do we express it in terms of sine? Just send it on to the other side. Cos 2 theta can be written as 1 minus 2 sine square theta. Cos 2 theta can be written as 1 minus 2 times sine square omega t. If this is 2 theta here, should be theta here. In place of theta, we are having 2 omega t. So I'm writing it as 1 minus 2 sine omega t. I hope you're following. Cos 2 theta can be written as 1 minus 2 sine square theta. Square, I forgot to write square here. So in place of theta, just put theta equal to omega t here. Theta equal to omega t. Okay. So that is how I have converted cos to omega t in terms of sine square, because sine square is the original given displacement. Now look at this one. Minus 2 omega square into a plus 4 omega square a into sine square omega t. So this is minus 2 omega square a plus omega square into 4 into y. This is the relation that we got. Is it satisfying SHM? What is our SHM relation? A equal to minus omega square into y. That's not happening. First of all, minus sign is missing here. Displacement and acceleration, there is no minus sign. That is one reason. Okay, and it is not same as yeah, that is missing. Second thing is there is an extra constant. That extra constant also not acceptable. Okay.
Okay.
Yeah. So both ways. There are two reasons to say that it is not SHM. This is not SHM. Can you try the next one? Do it quickly. Do it along with me. A omega cos omega t minus b omega sine omega t. And just differentiating it. Sine omega differentiation is cos omega differentiation is sine. And after differentiating cos, you'll get sine, and then they differentiate the inside part also. Okay, next differentiate it again to get acceleration. This is velocity, we got velocity, now we are getting acceleration. Right, so cos differentiation is minus. So minus a omega sine omega t is the differentiation of cos omega t, and extra omega will be there, so it becomes a omega square minus b omega sine differentiation is plus cos omega t. Differentiation of omega t is omega, so it becomes b omega square. So acceleration is equal to omega square, you just take it common, minus also common. What is remaining? See here, a sine omega t, this one. A minus omega square, I'm taking it common. Okay, only omega square I'm taking common, a sine omega t plus b cos omega t. In this equation, I'm taking omega square common, minus omega square common. What is left is a sine omega t plus b cos omega t, which is exactly same as y. See? So it is satisfying the perfect equation of SHM. So we can say, hence, this displacement equation that is given is satisfying the simple harmonic motion. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Good. So I'm moving ahead. If you are stuck in any problem, you just after the session, you just try to do it on your own. Okay. If you are still stuck, you can take my help later in the next session. Try to do this one. Come on, make it fast. You should know a little bit of differentiation to do these problems. You might have learned it in the first few sessions of physics classes. But since it happened 6 months back, I don't know how much you have remembered it. Simple differentiations. If at all, if you're not familiar with differentiation, I'll just tell you some things. D by dx of cos x is minus sin x. D by dx of sin x. Sin x differentiation is cos x. And cos x differentiation is minus sin x. Now, if you differentiate, instead of cos x, if you differentiate cos ax, then it becomes cos ax. It can be cos ax, or it can be cos ax plus some constant also. Cos differentiation is sine, we know that much, minus sine. Whatever is inside, just copy that, ax plus b. And whatever is inside, that you have to differentiate, d by dx of ax plus b, which is minus sine of ax plus b into differentiation of ax plus b is just a. Which means if you differentiate cos, it is minus sine. That much is clear. Whatever is inside part, just copying. Whatever is the variable with respect to which you are differentiating, beside that variable, some constant is there. No, that will come out. Because of this differentiation, that variable, that constant will come out. Simple.
Sir, it is not SHM, sir.
Very good, Rahari. Very good. Similarly, sine of ax plus b, this cos of ax plus b. That constant, you just write it out. As simple as that. One more differentiation. X to the power of n, we can write it as x to the power of n plus 1. Sorry, x to the power of n minus 1. N into x to the power of x n minus 1. Simple differentiations. These are the differentiations that we use frequently. If you're not familiar, these are the I have written here. From these two, these are also very simple to remember. If sine differentiation is cos, means cos differentiation is sine, but there is a minus sign or not, that is the question. Remember, the sine differentiation is cos. Then cos differentiation is not sine, it is minus. And if there is an extra constant multiplied to the variable, that constant will come out. There is not much to remember here. Just try to link. Okay, so it is cos omega t. I'm just doing it quickly because I've given you the formula also here. Minus 2 omega into sine 2 omega t. D square y by dt square is equal to cos differentiation is minus sine omega t. And this is minus 2 omega whole square. My mistake here. I think I did not write omega here. Forgot omega.
Yes.
The constant will come outside, as I told you here. That constant, whatever is the constant multiplied to the variable. Here I have shown you the formulas with respect to x. Instead of x, we are having t here. T is the variable. Beside the variable, whatever is the constant, that should come outside. Next, again, differentiation, omega cos omega t, differentiation is, cos differentiation is minus sine. And whatever is the constant available inside, that will come outside. So it will become, already omega is there, another omega will come outside, it will become omega square. Sine to omega t differentiation is cos to omega t. Cos 2 omega t. In place of a, we are having 2 omega. In place of x, we are having t. So that 2 omega should come outside. Already 2 omega is there. Another 2 omega, it will be 2 omega square. So this is acceleration. So acceleration equal to, so minus omega square, you can take it common. It becomes sine omega t plus 4 cos 2 omega t. This is not same as minus omega square times y. See? The sine omega t plus cos 2 omega t, but this is sine omega t plus 4 cos 2 omega t. So a equal to minus omega square y relation is not satisfied. Hence, it is not simple harmonic motion. Okay. I hope you're following.
Yes, sir.
There is not much we have done here. We have only done differentiation. There is none. What is the only concept, that thing that we are using in the 5 problems is this relation being satisfied or not? We are just checking that. With the help of differentiation, we are checking. Okay. Right. So if at all, if you are finding trickiness and the difficulty in these problems, it means your differentiation basics are a little weak. You just have to work on it. That is the only thing. The concept of SHM is not tough in these problems. Right. So let's understand a point here. 2 sinusoidal signals here. 2 sinusoidal signals here, but one is SHM and the other one is not. Why? I'll write that one. Whatever we have discussed in the previous slide, I'll write it so that you'll get some understanding here. Y equal to cos omega t plus sin omega t, or sin omega t plus cos omega t also you can write. This is SHM. Now try to understand, whenever you have multiple sinusoidal signals, okay, let's say 2 sinusoidal signals, cos and sine, then will it be SHM or not? That is the question. It will be SHM. See here, because the frequency is not same here. See, angular frequency. It is 2 omega here. That's why 2 omega square came outside. Because it is omega square came outside here. Because it is 2 omega is the frequency here, 2 omega square came outside. For this one, since only omega is there inside both of them, when you do differentiate twice, what happens is omega square is coming outside for both of them when you do differentiate twice. Omega square is coming common. So hence it is satisfying the SHM relation. So point is, when you have 2 sinusoidal signals, sine or cos, or both sines, both causes, anything is fine. The combination will be SHM only if the frequency is same. Angular frequency or frequency will be same. Or time period also will be same. Correct? Simple phenomenon. When you differentiate twice, what should happen? That constant is coming outside twice, no? See, whatever is the constant here, that is coming outside by squaring. Twice it is coming outside. Whatever is the constant inside, that is coming out twice. And it is being in the form of squared form. If that constant is not same, this relation will not be satisfied. If that constant is same like this, if that constant is same, then this relation will be satisfied. Correct? So the point is, when you have 2 sinusoidal signals, the combination of one sinusoidal signal, we know that it is SHM. If displacement is varying as a function of one sinusoidal function, we know that it is SHM. But when displacement is expressed as sum of 2 sinusoidal functions like this or like this, then we have to understand whether it is SHM or not. It is SHM only if the frequencies are exactly same. When the frequencies are exactly same, that is when it becomes SHM. When the frequencies are different, it is not SHM. Why? We have seen this here. When you do differentiate twice, the constant that is coming outside is different. So that's why it is not satisfying this relation. Only when the frequencies are same, it is satisfying this relation. Okay. And one more thing is, when the frequencies are different, you can't express it as single cos or sine signal like this. You can't express it as single cos signal like this or single sine signal like this. We can't express. But whereas this function, we'll see in future classes, that this can be expressed as some constant times cos of omega t plus some phase, something like that. We can express it like this. Two sinusoidal signals with same frequency, we can express it as a single sinusoidal signal like this with some phase, some other phase. Here the phase is zero, but here you can express combination of both of them, something like this. So you can think of it like this, okay? You can think of it like this. See, when you add two vectors, cos and sin, I told you that there is a 90-degree difference, no? When you're adding these two, it's like adding two vectors. Imagine it as like adding two vectors. When you add these two vectors, you'll get some vector, no? Some resultant vector, which is making some angle phi. So this is something like that. If you think of this as cos, and this is think as sine, adding two vectors, the resultant. Only if the frequencies are same, you can do that. If the frequencies are not same, you cannot add them like that, and you cannot create a single function like this. Okay. I guess you're following. I'll tell you one more. I'll ask you one more. Y equal to 10 cos omega t plus pi by 4 plus 20 cos omega t minus pi by 3. Will this be SHM or not? Will this be SHM or not? You can apply anything that you want. You can go from the very basic also. You can apply this also. Just differentiate it twice, no? Is omega square coming outside from this? Is omega square coming outside from this? Yes. Same omega square is coming out of both of the terms because same angular frequency they're having. So this will be definitely SHM. The point is, don't think that sir, one cos should be there, one sine should be there. Then the combination of one cos and one sine will become SHM. Not like that. It can be both cos terms, both sine terms, one cos, one sine. Anything is fine. Anything is fine, but the angular frequency should be same. Then it will be SHM. Should we remember it? You don't need to buy hard. You're just checking whether it is satisfying this relation or not. You can double differentiate this. And see you can express it like this or not. Hope you're following. Not clear?
Yes, sir.
Okay, I'll ask you one more also then. How about this one? Is it SHM or not? Come on. It's easy stuff.
Sir, it will be SHM.
Yes.
Why?
Yes,
Because
SHM.
when you differentiate this once, 2 omega will come outside.
2 omega and also that's it also it will be 2.
Same angular frequency.
Yes.
Angular frequency. Yes, it will be SHM. Forget about what is the remaining part. What is the phase here? What is the phase here? It should not matter when you're talking about SHM. Whether it is SHM or not, when you're checking that phase is immaterial for us. Because when you're talking about SHM, this is the condition that should be satisfied. When you differentiate twice, this phase has no significance when you're differentiating. No, see here, this phase here, that B is not at all impacting the differentiation. What is the B value? It is not impacting the differentiation. Whatever is beside the variable, that is only coming outside. Whatever is the omega angular frequency, that is only coming outside after the differentiation, not that constant. When you differentiate this, phi 1 will not have any effect on differentiation. Okay, phi 1 will not change the differentiation value if there is whether there is phi 1 or not. Hence, it is SHM. Finally, the conclusion is when you have a combination of cos or sine, both causes, both sine, one cos, one sine. Any combination is okay. You add two sinusoidal signals, both causes, both sine, one cos, one sine, with same angular frequency, then it will be SH. Why? Because when they have same angular frequency, when you differentiate wise, same thing will come outside, and hence you can express it as A equal to minus omega square into displacement. That's why. Okay.
Yes.
Fine then. So we've discussed about some questions in today's session. In tomorrow's session, we'll talk about. We already know the relation between displacement, velocity, and acceleration, but we will try to deep dive and we'll try to understand a little bit more about that so that we can solve a lot of questions easily. Okay, so we'll do that in tomorrow's session. So we'll take we'll stop at this place. We'll continue in tomorrow's session. Okay.
Okay.
Fine then. Take care. Good night.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.